All right, we're going to cover applications of quadratics, and the first one is a geometry application. So a man has a farm that is adjacent to a river. You can see that blue river. Suppose he wants to build a rectangular pen. You can see that in black for his cows. Here's his cows. If one side of the pen is the river, his cows will not swim away. What is the area of the largest pen he can build? Well, the most important thing so far is that we only have 500 feet of fencing. So we're going to call this side X, and that has to be the same length as this side. Now, what if this length we chose to be 20 feet? Well, then this side will have to be 20 feet. How much fencing is remaining for this side right here? Well, that would be 500 feet minus 2 times the 20 feet on the sides. Well, how can we rewrite that as just in terms of variables? Because we don't know that X is going to be 20 feet. It could be 40, it could be 100, it could be 15, 20, 20, we don't know. So this side here is going to be 500 feet minus 2 times whatever I've chosen for my value of X. Okay, now we are trying to make the largest pen possible. We're trying to maximize the area. Maximize area. So remember, area is equal to length times width. So in this case, we have area is equal to X times 500 minus 2X. That's length times width, or width times length. So I'm just doing this times this, length times width, or width times length. Okay, I'm going to now just multiply through. So I get area is equal to 500X minus 2X squared. And I can rewrite this in standard form as a negative 2x squared plus 500x plus 0. Okay, how do we maximize something? Well, we have to find the vertex. And it makes sense that we have a negative unhappy parabola. Remember, the negative 2x squared means it's unhappy. That means we're looking for our vertex. So I'm going to find the opposite of b over 2a to find my vertex. So that's going to be a negative 500 over 2 times negative 2. Well, that gives me negative 500 divided by negative 4. And what is that? That is 125. So that means to maximize our pen, our cow pen, our X value is going to be 125. And we certainly could take this 125 and plug in right here, and that would get us our value right here, which would be the largest pen possible. But that might not make the most sense to you. You might want to go back to this picture right here and say my X is 125. This right here is 125. Okay, what's 500 minus 2 times 125? Well, 500 minus 2 times 125. Well, what is 2 times 125? That's 250. 2 times 125 is 250. What's 500 minus 250? Well, that is 250. So our area is going to be length times width, which is 125 times 250, or 250 times 125. And I get an area of, I'll just write this here, 31,250 square feet would be the maximum. And the dimensions would be a 250 by 120 foot fence. And again, like I said, if you wanted to, you could take this 125 and plug it into X here and here, and you would get this 31,250 for that Y value. Okay, here's another geometry example. The top of a coffee table is 3 feet longer than it is wide and has the area of 10 square feet. What are the dimensions of the coffee table? All right, well, let's go ahead and let's do a coffee table here. Okay, not my best picture, but you get the idea. So we've got a coffee table that is 3 feet longer than it is wide. So I'm going to call that its width, and then I'm going to call this width plus 3, because the top of the coffee table is 3 feet longer than it is wide. So in reality, our picture actually looks a little bit more like this, because your length here is 3 feet longer than it is wide. Okay, so then we know that the area of this is going to be W times W plus 3, or the area is going to be W squared plus 3W. But we are also told that the area of the coffee table is 10, or 10 square feet. Don't get confused with this square foot thing. That's just the units. So I'm going to erase this A, and I'm going to put a 10. So now I need to solve for 0, because I always set things equal to 0 before solving quadratics. So I'm going to subtract 10 from both sides. So I get 0 equals W squared plus 3W, and then minus 10. Well, we can actually factor this. We can think about what adds to 3 and multiplies to negative 10. Well, that would be 5 and negative 2. So I can rewrite this as W plus 5 and W minus 2. So let me just make sure that works. 5 times negative 2, yep, that works. 5 minus 2 is 3, yep. So my answer is going to be a W equals negative 5 and a W equals 2. Well, which one doesn't make any sense? Well, it doesn't make sense for the width of a table to be negative 5, so that's not a good answer. And you'll always have one that doesn't make sense. But W equals 2 makes sense. So we would have W equals 2, and this would be 2 plus 3 is 5. Okay, so you would have, and this totally makes sense, right? Isn't the width 3 more than that? Yes. And isn't the area 10? Well, yes, 5 times 2. So what are the dimensions? Well, it's going to be a 5 by 2, right? If our W is 2, we have 2 plus 3 is 5. So it's going to be a 5 by 2, which you might have been able to do in your head, but I would certainly say that they get harder than that, and you can't always do it in your head. So that's the application of geometry. And we have more applications, but I'll cover that in my next video.